Hi guys, welcome back to another update for VKEngine. This week I've added support for Frustum Culling, which is a crucial optimization in 3D games. I've also enabled debug visualizations for the AABBs used in the visibility test, as well as the submesh level bounding boxes used for collision detection. And I've added 3D audio using the Solid library. Additionally, I've heavily optimized the renderer, making sure to reuse the visibility data as much as possible to avoid redundant computations, and I'm merging as many draw calls as I can. So here we are in the engine. As you can see, there's quite a lot going on in this scene. So let me show you around. Firstly, we have this 10 by 10 grid of cubes and a 4 by 4 grid of transparent windows. You'll notice that one of the cubes is moving, and that's to demonstrate the transformations of the AABBs. So if I enable the debug visualization, you can see that as the cube transforms, the AABB tracks it closely. However, as the cube rotates, the AABB no longer tightly hugs the cube, and I think this is just an inherent limitation of AABBs. So if you want to resolve this behavior, you would need to use an OBB or oriented bounding box, which is more computationally expensive. Anyway, let's look at the Frustum culling. So if I keep only a subset of these cubes and windows in frame, and I freeze the camera frustum, when we turn around, we see that everything else has disappeared. Since it's no longer being rendered, we're only rendering the exact cube instances and windows that we need to see. Now, if you look up, you'll see a giant grid of 10,000 cubes. And this is my favorite way to demonstrate Frustum culling. So if we fly into the middle of the grid and freeze the camera frustum, when we move out, you can actually see the shape of the camera frustum formed by the remaining cubes which haven't been called out. Now next I want to show you the submesh level AABB visualizations. Let's fly inside Responder and enable that. You can see that each submesh maintains its own bounding box. And I'm using these for collision detection in my game prototype, which I'll demonstrate next. So here we are in the next demo. This is my sponsor adventure game I uploaded, but I've made some improvements. Now it has 3D audio, so I've disabled the background music, and you can observe as we move towards this ring object, you can hear the sound start to fade in. And it also supports panning, so if I'm on one side of the ring, it sounds as if the audio is coming from the correct position. And now I'm also using the submesh level AABBs to perform collision testing with the geometry. So you can see that we can no longer pass through the scenery. We have to actually move around it like a real game level. Now, if you're interested in some implementation details, how the CPU culling works, how I'm grouping instances, the index buffer merging optimization, and the GPU indirection setup, I've written a detailed breakdown in README for this episode, linked in the description. So here's the roadmap for VKEngine. The next thing I'll implement is shadows, and I should be able to reuse some of the Frustum culling implementation there, since the sunlight acts as a view frustum, so we can just plug that directly into the visibility test. Then there are a bunch of more things I want to work on. Previously in my OpenGL project, I implemented some post-processing using a full-screen quad, but I think the more modern way is to just do everything in compute shaders. And I want to move to a more sophisticated algorithm than forward shading. So I was initially aiming for deferred rendering, i.e. tiled deferred plus a forward pass for transparency/MSAA, but I'm also aware of cluster shading, which is really just an extension of tiled into 3D space, I believe. It's more complex, so I'm looking at some reference implementations. Anyway, thanks for watching as always. Don't forget to subscribe to follow the development of his projects. I've been pushing out weekly devlogs, and I tend to keep his cadence up. Also, if you want to learn computer graphics, you can check out the resources on my website. Thanks.